The blinking lights are a direct result of the inrush current demanded by the new, more efficient air conditioning unit during startup. This inrush current creates a brief but significant voltage drop across the service conductors supplying power to the house. Let's delve into the reasons why this occurs and explore the limitations in resolving this issue. Electrical systems are designed to operate within specific voltage ranges. When an appliance, particularly one with a large motor like an air conditioner compressor, starts, it requires a surge of current to overcome the inertia and magnetic fields within the motor. This initial surge is known as the inrush current, and it can be several times higher than the normal running current of the appliance. In the scenario described, the air conditioner draws 180 amps upon startup. This sudden demand for current causes a temporary voltage drop along the electrical conductors. The voltage drop is governed by Ohm's law, which states that voltage equals current times resistance. The service conductors, while sized appropriately for the overall load of the house, still possess a small amount of inherent resistance. When a large current flows through these conductors, even a small resistance can lead to a noticeable voltage drop. This voltage drop is not isolated to the air conditioner circuit, it affects the entire electrical system of the house. Lights, being particularly sensitive to voltage fluctuations, are the most noticeable indicators of this voltage drop. Incandescent lights dim momentarily, while LED lights may flicker or change in brightness. The steps taken, such as increasing the wire gauge and transformer size, were aimed at minimizing the voltage drop. Firstly, upgrading the aluminum wiring from 6 American wire gauge to 1 American wire gauge reduces the resistance of the conductor. Secondly, replacing the 25 kV ampere transformer with a 50 kV ampere transformer increases the capacity of the transformer to deliver current and reduce the voltage drop. Thirdly, upgrading the service cable from 2/0 to 4/0 also reduces resistance. The underlying issue is the fundamental nature of motor startup. There are practical limitations to how much the inrush current can be reduced without significantly impacting the efficiency and performance of the air conditioner. Motor soft starters are available, but may not be compatible with all air conditioning units. These devices gradually increase the voltage applied to the motor during startup, reducing the inrush current. However, they also add complexity and cost to the system. Another potential solution is to use a different type of motor in the air conditioner. Some newer air conditioners use variable speed compressors that do not have the same high inrush current as traditional compressors. These compressors start slowly and gradually increase speed, drawing less current during startup. However, replacing the existing air conditioner is a significant expense. The utility company upgraded the transformer and service cable to minimize voltage drops. These measures improve the overall voltage stability of the electrical system. However, the inherent voltage drop during motor startup cannot be completely eliminated. Even with larger conductors and a more robust transformer, the inrush current will still cause a temporary voltage drop. The suggestion that nothing can be done is not entirely accurate, but it reflects the practical limitations of addressing the problem. While technical solutions exist, they may be costly, complex, or not fully effective. The voltage drop is a short-duration event that does not pose a safety hazard or damage electrical equipment. The blinking lights are simply an annoyance. Here's a more detailed explanation of the factors involved. Conductor resistance. All electrical conductors, including copper and aluminum wires, have some level of resistance. Resistance is measured in ohms. The longer the conductor and the smaller the cross-sectional area, the higher the resistance. The American wire gauge, or OG, system is used to standardize wire sizes. A smaller AWG number indicates a larger wire size and lower resistance. Aluminum has a higher resistance than copper, so a larger aluminum wire is needed to carry the same current as a copper wire. In this case, the builder initially used 6 American wire gauge aluminum wire, which has a relatively high resistance. Replacing it with 1 American wire gauge aluminum wire significantly reduces the resistance, allowing more current to flow with less voltage drop. Transformer capacity. Transformers are used to step down the voltage from the high voltage distribution lines to the lower voltage used in homes. The capacity of a transformer is measured in kilovolt amperes, or kVA. A larger kVA transformer can supply more current without experiencing a significant voltage drop. The utility company replaced the 25 kilovolt ampere transformer with a 50 kilovolt ampere transformer, which doubles the capacity of the transformer. This helps to maintain a more stable voltage during periods of high demand, such as when the air conditioner starts. Service cable size. The service cable is the main cable that connects the house to the utility's electrical grid. The size of the service cable is also a factor in the voltage drop. A larger service cable can carry more current with less voltage drop. The utility company replaced the 2/0 service cable with a 4/0 cable, which is a larger size. This also helps to reduce the voltage drop during periods of high demand. Inrush current characteristics. The inrush current of an air conditioner compressor is a transient event. It lasts for only a fraction of a second. The magnitude of the inrush current depends on several factors, including the design of the compressor motor, the voltage applied to the motor, and the load on the compressor. In some cases, the inrush current can be reduced by using a soft starter or a variable speed compressor. However, these options may not be practical or cost-effective in all situations. System impedance. The impedance of the entire electrical system, including the wiring, transformer, and service cable, affects the voltage drop. Impedance is a measure of the opposition to the flow of alternating current. A lower impedance system will have less voltage drop. The upgrades made to the wiring, transformer, and service cable all contribute to reducing the overall impedance of the system. Code compliance. Electrical installations must comply with the National Electrical Code, or NEC. The NEC specifies the minimum size of conductors and other electrical equipment based on the expected load. The upgrades made to the wiring, transformer, and service cable ensure that the electrical installation complies with the NEC. Mitigation strategies. While it may not be possible to completely eliminate the voltage drop, there are some mitigation strategies that can be used. One option is to install a dedicated circuit for the air conditioner. This would isolate the air conditioner from other circuits in the house and reduce the impact of the inrush current on other appliances. Another option is to use a soft starter or a variable speed compressor, as mentioned earlier. These devices can reduce the inrush current and minimize the voltage drop. In conclusion, the blinking lights are caused by the inrush current of the air conditioner compressor. The upgrades made to the wiring, transformer, and service cable have helped to reduce the voltage drop, but it may not be possible to completely eliminate it. While mitigation strategies are available, they may not be practical or cost-effective in all situations. The electrical system is designed to operate within specific voltage ranges, and voltage drops are a normal occurrence during motor startup. The duration of these voltage drops is short and don't pose a safety hazard or damage to electrical equipment. The best course of action is often to accept the blinking lights as a minor inconvenience. Additional considerations. Power factor correction. Power factor is a measure of how efficiently electrical power is used. A low power factor can increase the current flowing through the electrical system, leading to a larger voltage drop. Power factor correction capacitors can be installed to improve the power factor and reduce the current. This may help to reduce the voltage drop during air conditioner startup. Harmonic distortion. Harmonic distortion is the presence of unwanted frequencies in the electrical system. Harmonic distortion can also increase the current flowing through the electrical system and cause voltage drops. Harmonic filters can be installed to reduce harmonic distortion. This may also help to reduce the voltage drop during air conditioner startup. However, in most residential situations, power factor and harmonic distortion are not significant contributors to voltage drop issues. Sizing of conductors. Conductors must be sized appropriately based on the load they will carry. The National Electrical Code, or NEC, provides guidelines for sizing conductors. The NEC specifies the minimum size of conductors based on the ampacity, which is the maximum current that a conductor can carry safely. The NEC also provides guidelines for dirting conductors, which means reducing the ampacity of a conductor if it is installed in a hot environment or if it is bundled with other conductors. Voltage drop calculations. Voltage drop calculations are used to determine the voltage drop in an electrical circuit. These calculations take into account the length of the conductor, the size of the conductor, the current flowing through the conductor, and the power factor. Voltage drop calculations can be used to ensure that the voltage drop in an electrical circuit is within acceptable limits. The NEC recommends that the voltage drop in a branch circuit not exceed 3% and that the voltage drop in a feeder circuit not exceed 5%. Grounding and bonding. Grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to flow back to the source, which helps to protect people from electric shock. Bonding connects all of the metal parts of an electrical system together, which helps to prevent voltage differences between different parts of the system. Proper grounding and bonding are essential for ensuring the safety and reliability of an electrical system. Surge protection. Surge protection devices, or SPDs, are used to protect electrical equipment from voltage surges. Voltage surges can be caused by lightning strikes, power outages, and other events. SPD divert the surge current to ground, which helps to protect electrical equipment from damage. SPD should be installed at the service entrance and other locations in the electrical system where sensitive equipment is located. Insulation resistance. Insulation resistance is a measure of the quality of the insulation on electrical conductors. Low insulation resistance can indicate that the insulation is damaged or deteriorated. Damaged insulation can create a safety hazard and can lead to electrical faults. Insulation resistance should be tested periodically to ensure that the insulation is in good condition. Thermographic inspections. Thermographic inspections use infrared cameras to detect hotspots in electrical equipment. Hotspots can indicate that there is a problem with the equipment, such as a loose connection or overloaded circuit. Thermographic inspections can be used to identify potential problems before they cause a failure. Power quality monitoring. Power quality monitoring equipment can be used to measure the voltage, current, and other parameters of an electrical system. This equipment can be used to identify power quality problems such as voltage sags, voltage swells, and harmonic distortion. Power quality monitoring can help to ensure that the electrical system is operating properly and that electrical equipment is protected from damage. Regular maintenance. Regular maintenance is essential for ensuring the reliability and safety of an electrical system. Regular maintenance should include inspecting the wiring, tightening connections, testing the insulation resistance, and checking the grounding and bonding system. Regular maintenance can help to prevent electrical problems before they occur. Consulting with an electrician. If you have any concerns about the electrical system in your home, it is important to consult with a qualified electrician. An electrician can inspect the electrical system and identify any potential problems. An electrician can also recommend solutions to any electrical problems that you may have. The final assessment reveals that while upgrades have been implemented, the inherent physics of motor inrush current and conductor impedance mean the blinking lights are likely to persist. Focus on maintaining a safe and code-compliant electrical system, and consider the blinking lights an unavoidable side effect of modern, efficient air conditioning technology. While solutions like soft starters or variable speed compressors exist, their practicality depends on individual circumstances and cost-benefit analysis. If the blinking is a significant issue, exploring these alternatives with a qualified electrician may be worthwhile.